Hello everyone. In the previous lecture, we have solved a numerical problem in which we have applied the given velocity profile to determine displacement thickness, momentum thickness and energy thickness. However, in that case, the velocity profile that we considered was of very simple nature, and that's why problem became a very basic problem so that you get used to the basic formulas of all the three parameters. Now that you have a practice of using those formulas and performing the integration, we can proceed further with a complicated velocity profile. So the problem statement for this numerical is as follows. We need to find out displacement thickness, momentum thickness and energy thickness when velocity distribution in the boundary layer is given as small u upon capital U is equal to 2 times y by delta minus y by delta whole square. In this case, y indicates distance away from the flat plate and delta indicates the boundary layer thickness, u is local velocity of that fluid layer and capital U is the free stream velocity. And because of boundary layer assumption, boundary layer conditions, at a distance y is equal to delta, the velocity of the fluid layer will be as good as the free stream velocity. So now let us proceed with the solution of the problem. First thing is the given thing. So the velocity distribution which has been given to you is in front of you. First parameter to be evaluated is displacement thickness, delta star. We already know the mathematical formula for that. Delta star is integration of the term 1 minus small u upon capital U with respect to dy within the limits. Lower limit is 0 and upper limit is delta. This logic has already been explained in the previous lectures. So substituting the value of velocity profile, that is ratio of small u to capital U, we get instead of small u and upon capital U, we are going to replace this entire given velocity profile. So that becomes delta star is equal to integral 0 to delta of 1 minus the entire term 2 times y by delta minus y by delta bracket square with respect to y. So now let us split the terms properly. This negative sign should be absorbed inside the bracket, so that becomes 1 minus 2 times y by delta, and this negative and the second negative, they make each other totally positive, so that's why 1 plus y by delta whole square. Now that all the terms have been resolved properly, we are able to perform integration. So integration has been performed. Let us proceed step by step because now multiple terms are involved in this numerical. This will be our approach throughout. We will resolve one term one by one. So integration of 1 will be y only, that's why y. Integration of delta will not happen as we discussed in the previous lecture also. It is a constant parameter, that's why it will remain as it is. Only integration of y terms will take place. So integration of y is y square by 2 and it is multiplied by 2 upon delta. So 2 times y square by 2 upon delta plus integration of y square will be y cube by 3 and 1 upon delta square as it is. Now that integration has been performed, we will put in the limits of integration. Upper limit is delta, lower limit is 0, so we will not waste our time in writing 0 and calculating the terms related to it. This will save our writing time as well as space, so we will directly proceed with replacement of delta as the limit of integration. Delta replaced with y will give us only delta. Delta replaced for y square will give us delta square upon delta because 2 will be absorbed from numerator as well as denominator. Then delta cube upon 3 delta square. So delta square upon delta is a single delta. So delta minus delta will be 0 and your final answer will be one more thing. This delta square will be eliminated from numerator as well as denominator. That's why your final answer will be delta by 3. This is your displacement thickness. So we have our first answer. Now we will proceed with the second answer. Second answer is momentum thickness theta. We know the formula is similar to the formula of displacement thickness, only with the addition, or rather we should say multiplication of the term u upon u. So this one is displacement thickness 1 minus small u upon capital U into dy multiplied by again one more velocity distribution small u upon capital U, and integration of this entire term within the limit 0 to delta We will substitute the value for small u upon capital U. Now you might realize that there will be multiple terms in this integration now, and that's why we need to deal with each term step by step. So let us proceed. Firstly, we will absorb this negative sign over here inside the bracket. So, and right now we will not touch this term. So this term is as it is, 2y by delta minus y square upon delta square as it is. In the second bracket, 1 minus 2y by delta and 1 minus plus. So that becomes plus. So 1 plus y square plus delta square integration with respect to y. Now we can perform multiplication. We will perform multiplication of only one term on the left hand side, on the left bracket, and all the terms on the right bracket. So firstly we will perform multiplication of 2y by delta with the whole bracket. Then we will proceed with multiplication of the second term with the whole bracket. So multiplication of 2y by delta with 1 gives us 2y by delta. Multiplication of 2y by delta with 2y by delta gives us 4y square by delta square, and this is negative over here, that's why it has been absorbed over here. Then 2y by delta multiplied by y square upon delta square, so that gives us 2y cube upon delta cube, that's 2y cube upon delta cube over here. So multiplication of first term from the left bracket with the entire right bracket has been completed. It has given us 3 terms. Now 3 more terms are remaining. We will proceed with that. So minus, inherently minus will be there whenever we are multiplying. So minus y square by delta square into plus 1. So that gives us only minus y square by delta square. Minus y square by delta square into minus 2y by delta. So that gives us minus 2y cube upon delta cube. So this minus and this minus, they become plus. So that gives us finally positive 2y cube upon delta cube. Now this minus y square by delta square and this positive y square by delta square, they give us negative y raised to the power 4 and delta raised to 4. Integration of everything now should be done with respect to y. But still, we still need to simplify all these terms. We can find out the common terms in here. We have only one term which has coefficient y by delta, so that is 2y by delta on its own. We have 2 terms which have y square by delta square as the coefficient. So y square by delta square is multiplied over here by minus 4, and it has been multiplied by minus 1 over here. So minus 4 and minus 1, that becomes minus 5 times y square by delta square. Then we have one term of y cube by delta cube which has coefficient of 2, and then we have second term of y cube by delta cube which is again multiplied by 2, and both are positive parameters. So plus 2, 4 times y cube by delta cube that we get. There is only one term of y raised to 4 upon delta raised to 4, so that is only, and it is also associated with negative sign, so that's why this will be only minus y raised to 4 upon delta raised to 4. So our final will be 2y by delta as it is, minus 4 minus 1 y square by delta square, that's why minus 5 y square by delta square, plus 2y cube by delta cube plus 2y cube by delta cube, that will give us 4 times y cube by delta cube, minus, my mistake, minus y raised to 4 upon delta raised to 4. So now you see that previously there were 6 terms after the total expansion of the 2 brackets. Now there are only 4 terms. So that mathematics has been reduced, our further efforts will be reduced, and also chances for error in the final answer, they will be reduced. So now let us proceed with the integration. Again, delta will not be integrated, no term of delta will be integrated, they will remain as it is, only the terms related to y will be integrated. So integration of y will be y square by 2, integration of y square will be y cube by 3, integration of y cube will be y raised to 4 by 4, and integration of y raised to 4 will be y raised to 5 by 5. So let us proceed with that integration. It gives us 2 times y square by 2 delta minus 5 times y cube by 3 delta square plus 4 times y raised to 4 by 4 delta cube minus y raised to 5 by 5 delta raised to 4, and within the limits 0 to delta. Now let us apply the limits of integration. This 2 will be absorbed from numerator as well as denominator. This 4 will be absorbed from numerator and denominator. We are doing all these things in such minor details because of which we should be able to reduce our errors as well as we can reduce our efforts. So now let us proceed. So that gives us delta square upon delta for the first term, then 5 by 3 delta cube by delta square negative, then delta raised to 4 upon delta cube positive, this expressed over here like this, then delta raised to 5 upon 5 times delta raised to 4 like this term. So this first thing, only delta will be absorbed from numerator and denominator, that will give us delta. Second term gives us 5 by 3 delta, third term gives us 1 positive delta, and last term gives us minus 1 by 5 delta. So in this case, if we want to perform this operation, this complete calculation, we should have a common multiplier or LCM at the denominator. So that's why the least common multiplier for 3 and 5 is 15. So we should take care that denominator for all the terms in here should be 15. So let us see what we can do. We will multiply first term by 15, second term by 5, third term by 15, and last term by 3. So we get 15 delta minus 25 delta plus 15 delta minus 3 delta. So this minus 25 and minus 3 is minus 28, and this positive 15 and this positive 15 is 30. So 30 minus 28 gives you 2 delta upon 15. So that's written over here, 30 delta minus 28 delta upon 15. So that gives you 2 delta upon 15. So this is the answer for the momentum thickness. One thing you must have understood by now is that by careful treatment of each and every term calmly helps us to arrive at the solution easily, quickly, and with minimum error possible, rather minimum chances of error itself. With the similar calm approach, we will proceed for the energy thickness. Until now, we have dealt with displacement thickness and momentum thickness. Increasing the brackets over here, increasing the terms over here, increases the span of the solution downstream. So we need to be much more careful with the energy thickness because it has complicated terms. So let us go with the energy thickness. Energy thickness, as we know, it is given as delta double star is equal to integral from 0 to delta of the term u upon capital U into the bracket 1 minus small u square upon capital U square with respect to y. So firstly, we will only replace the value of small u upon capital U inside the bracket and small u square upon capital U square. We will perform this operation in the next step. So this is only the value replacement. Now remember, this will be a total bracket square. So firstly, we will expand this bracket, then reduce the terms, provide them with appropriate signs, and then only we will proceed with multiplication and then with the integration. So firstly, let us expand this bracket. This is similar to the fundamental equation a minus b bracket square. So we know that it is a square plus b square minus 2ab. So a square for this term can be considered as a. So a square is 4y square by delta square. Second term is b. So its square is y raised to 4 upon delta raised to 4. It will be positive. Remember, square of negative will be positive. Minus 2ab. Minus 2ab, it means minus 2 multiplied by 2y by delta into y square upon delta square. So that gives you 4 times y cube upon delta cube negative. So now let us firstly absorb this negative sign inside the bracket and balance the terms. So that gives us 1 minus 4y square by delta square minus y raised to 4 upon delta raised to 4, and this minus becomes plus. So 1 plus 4y cube upon delta cube. Now that we must understand, on the left bracket we have 2 terms, in the right bracket we have 4 terms. So multiplication will give us 8 terms. Then using the similar approach that we followed for momentum thickness, we will try to reduce the number of terms by identifying the common multipliers or coefficients. So let us proceed with the multiplication. So firstly, again similar approach, we will multiply the first term from the left bracket with the entire right bracket. Then we will multiply the second term in the left bracket with the entire right bracket. So now, firstly, 2y by delta multiplied by 1 as it is. then 2y by delta multiplied by minus 4y square by delta square, so that gives us 8 times y cube by delta cube negative. Then 2y by delta into negative y raised to 4 upon delta raised to 4, so 2 times y raised to 5 upon delta raised to 5 negative. Then 2y by delta into 4y cube by delta cube, so that gives you 8y raised to 4 upon delta raised to 4 positive. So now these first 4 terms belong to multiplication of the second bracket with the first term of the first bracket. So now we'll proceed with the multiplication of the second term from the first bracket with the entire second bracket. So multiplication of minus y square by delta square into 1, so that gives us minus y square by delta square. Then multiplication of minus y square by delta square into minus 4y square by delta square, so that gives us 4 times y raised to 4 upon delta raised to 4 positive. So this becomes positive 4 times y raised to 4 upon delta raised to 4. Then minus y square upon delta square into minus y raised to 4 upon delta raised to 4. So it gives you y raised to 6 upon delta raised to 6, negative negative balance each other, so that becomes positive. So y raised to 6 upon delta raised to 6 positive. And the last term minus y square by delta square plus 4y cube by delta cube, so it gives you 4 times y raised to 5 upon delta raised to 5 negative. Now our next step will be simply to find out the common terms in all these, so that we can reduce the number. For simplicity, we have copied the previous term on this page also, so that we can commit minimum mistakes and we can reduce our efforts. Now what we need to do, we need to identify the terms having similar coefficient. For example, there is only one term of the coefficient y by delta. There is only one term of the coefficient y square by delta square. For y cube by delta cube, again only one term. There are two terms having coefficient y raised to 4 by delta raised to 4. One is having multiplier 8, second one is having multiplier 4. Then there is one term with respect to y raised to 5 upon delta raised to 5 having multiplier minus 2, and one more term having for y raised to 5 upon delta raised to 5 having multiplier minus 4. Then for y raised to y raised to 5 upon delta raised to 5, then for y raised to 6 upon delta raised to 6 there is only one term. So in the increasing order of y, we have isolated these terms so that total number of terms can be reduced. You should observe that firstly there were 1, 2, 3, 4, 5, 6, 7, 8 terms. Now there are only 6 terms. This makes our calculations easier and creates lesser scope for making the errors. Now we will integrate. Integration of 2y by delta will be 2 times y square by 2 times delta, minus integration of y square will be y cube by 3 delta square, minus 8 times y raised to 4 upon 4 delta cube, plus 12 into y raised to 5 upon 5 delta raised to 4, minus 6 into y raised to 6 upon 6 delta raised to 5, plus y raised to 7 upon delta raised to 6. My mistake, y raised to 7 upon 7 times delta raised to 6. So that we have calculated over here. Now 2 will be absorbed from numerator as well as denominator. 8 upon 4 will give us 2, 12 by 5 as it is. This 6 and this 6 will be absorbed. So what remains with us after replacing the limits of integration is delta square by delta minus delta cube upon 3 delta square, minus 2 times delta raised to 4 by delta cube, plus 12 by 5 times delta raised to 5 upon delta raised to 4, minus delta raised to 6 upon delta raised to 5, plus delta raised to 7 upon 7 delta raised to 6. So in here one delta will be absorbed, here delta square will be absorbed, delta cube will be absorbed, delta raised to 4 will be absorbed, delta raised to 5 will be absorbed, and delta raised to 6 will be absorbed. So what remains with us is delta minus 1 upon 3 delta minus 2 times delta, plus 12 by 5 delta, minus delta, plus delta by 7. So now this positive delta and this positive negative delta will absorb each other. So what remains with us is minus 2 delta minus delta by 3 plus 12 by 5 delta plus delta by 7. Now, in this case, the common multiplier that we have, least common multiplier actually, is 105. So we need to take care such that the denominator of all the terms should be 105. So multiply by 105 for the first term. So we get minus 210 delta. In this case, what we need to multiply is 105 divided by 3. So 3 3s are 9 and 3 5s are 15. So we need to multiply by 35 over here. So we get minus 35 delta, plus we need to multiply over here by 105 divided by 5. So that is 21. So 21 into 12. So that gives us 252 delta positive, plus at this point we need to multiply this parameter by 105 divided by 7. So that gives us 15. So 15 times delta. So now for all the terms we have a common denominator 105. This is minus 210. This is minus 35. So that's minus 245. This is positive 252. So this becomes positive 7 delta plus 15 delta. So in total 15 plus 7, that's 22 delta divided by 105. This is the answer for energy thickness. Now in this numerical, my objective was to help you with handling so many terms of y by delta and perform mathematical operations, and then after perform the integration operation and substitution of limits of integral. This is what we have seen in this lecture. We will try to cover some more variety of numericals in the further lectures. If you like this lecture, subscribe the channel and press the bell icon. Thank you very much.